All right, let's do another limit. So the last one we did was a linear function. It was this one, and I'm say linear. It's like mx plus b. There's no x squared. There's no x cubed. Um, let's do one that is not linear, x squared. And still, the statement that we're going to prove is basically any Calc 1 student could tell you that this limit is true, but they couldn't provide you with the epsilon delta proof. Um, so let's do an epsilon delta proof. Uh, so again, I'm going to start with scratch work. For limits, you basically need to do some scratch work before you can really write a proof, unless you have a lot of experience and you can really see several steps ahead. Um, so what would I like? I would like if this is true, then this is true. So I would like x minus 1 less than delta greater than 0 to imply that f of x minus L inside of absolute values is smaller than epsilon. That's what I would like. So let's play with this. Um, what do these two things have to do with each other? We have some algebra, right? This is a difference of two squares. This, of course, the inside is x plus 1 times x minus 1, and it's in absolute values, so I would just put absolute value of x plus 1, absolute value of x minus 1. And if I'm assuming that this one is smaller than delta, then I would get to say that this is smaller than x plus 1 times delta. I would still, what I really want is for this to be smaller than epsilon. So the question is now, can I guarantee that this is less than epsilon? Well, it seems maybe a bit tough because I don't know what x is. I'm allowed to choose delta to be whatever I want in terms of epsilon, but it can't depend on x as well. Like, on the last one, I chose delta to be epsilon over 2. So maybe for this one, it's tempting to choose delta to be like epsilon over this or something. But if I divide by this, then it's depending on x, and that's bad. So I have to be careful about how I do this. What I need here, I need to make a statement about this quantity. I need to know something about x plus 1 inside of absolute values. So here's what we can say. Let's assume that delta is, say, at most 1. I'm just coming up with a specific number. I can choose any positive number I want. Delta just has to be a positive number. I can choose a positive number that's less than or equal to 1 if I want to. And this assumption is going to help me. because I know that the absolute value of x minus 1 is less than delta, and if I'm assuming that's less than or equal to 1, then that gives me a range of x's, right? I can take the absolute values off of this inequality and say that the thing inside the absolute value is between -1 and 1. And then I can solve for x. So x is from 0 to 2. So what am I really trying to do here? I was trying to figure out something about absolute value of x plus 1. Now, if I know that x is between 0 and 2, then x plus 1, yeah. X plus 1 is between 1 and 3. So then the absolute value, if x plus 1 is between 1 and 3, then it's already a positive number, so the absolute value doesn't do anything, and this is at most 3, just because that's the largest number in this range that we're talking about. If that's the case, then I can go back to where I was. Actually, let me make this a less than or equal to here. I wanted this to be strictly less than epsilon, but I already have a strict inequality here, so this one doesn't need to be strict. This can be less than or equal to. And I guess all I'm saying here is I can choose delta to be epsilon over, and if you remember, I wanted to divide by this. I'm not going to divide by this. I'm going to divide by the largest number it could be, which is 3. So let epsilon be, or let delta be epsilon over 3. Or actually, sorry, I keep changing my mind. Less than or equal to epsilon over 3. And then this will be satisfied. And why am I being so careful about this and changing my mind? Because we actually said 2 things about delta. I want delta to be at most 1. I also want delta to be at most epsilon over 3. So I'm about to try to write a formal proof, and in my formal proof I'm going to choose delta to be the min of these 2 things. Whichever number is smaller. I just want delta to be less than or equal to this number and also less than or equal to this number. So I'm just going to choose whichever one of these numbers is smaller. Delta is the min of 1 and epsilon over 3. And this is going to be a valid choice for delta as long as it doesn't depend on x. It only depends on epsilon. And as long as it's a positive number, which it is, because we assume epsilon's a positive number. So if 1's a positive number and this is a positive number, then the minimum of the 2 is also a positive number. Okay, so let's run through the proof. Once again, what are we proving? I'm proving this limit. And my proof is, all of these proofs start with the same sentence, let epsilon be greater than 0. Well, okay, it doesn't have to be a complete sentence. I'm going to write a comma, and delta be min of 1 epsilon over 3. And what do I have to oops, this is not the right piece of paper, it's this one. I have to show that if this, then this. So suppose this, meaning 0 is less than absolute value of x minus 1 is less than delta. Then now I'm hoping to fill in whatever reasoning I have to fill in to reach my conclusion, which is that f of x minus L is less than epsilon. So maybe now I will this is one of these proofs where I know what the last statement is going to be, so I'll just write it and I'll be optimistically hoping that we can fill in the reason. F of x minus L is less than epsilon. Okay, and let's just hope we can do that. I probably left myself way too much space, but it doesn't hurt. What do we want to attack? It's this amount. I mean, this is the amount I want to show is less than epsilon, so I'd better do something with it. And I'll do, again, I'm running through a lot of the same steps I already did in the Scratch work. It's just more formal now. This is the algebra that we did. We already know, okay, let me stop there. These two things are, let's consider them separately. This is the one that's less than delta. And delta is the min of these two numbers. So delta is less than or equal to 1. Delta is also less than or equal to epsilon over 3. That's how a min works. The min is less than or equal to each of these numbers. So I can say delta is less than or equal to, I could fill this in with a 1. I could also fill this in with an epsilon over 3. I'm going to fill this one with an epsilon over 3. So that's what I'm going to do with x minus 1. What am I going to do with x plus 1? Right. Well, what did we say about x plus 1 in our Scratch work? Here's our Scratch work. What I wanted to show is that x plus 1 is less than or equal to 3, and that's why we did what we did. So let me say that x plus 1 is less than or equal to 3 since, and I haven't justified this as part of my formal proof, but I should be able to just sort of copy the justification from my Scratch work. This is true since, right, once again, x minus 1, x minus 1 is smaller than delta, which is less than or equal to 1. And this is where I'm putting the 1 here. So that would imply, and once again I'm doing the same steps. I take the absolute value off. I put this in between -1 and 1. And I want to add 1 to everything, but actually, maybe let me make this go faster. I'm really interested in x plus 1, so let me just add 2 to everything. So I add 2 to everything, and we get this. And now this is enough to justify what I was saying. X plus 1 is a number between 1 and 3. these are positive numbers, so again, the absolute value doesn't do anything, and the biggest possible one is 3. So where are we? I was here. I took this absolute value. If you recall, this is the one that I want to ultimately be smaller than epsilon. I took it, I factored it, I said that this one is at most epsilon over 3, and I said this one is at most 3. Thus, maybe I'm writing too much here, but just to be clear, it's this factorization. This is less than, so this one was less than epsilon over 3. This one was less than or equal to 3. I'm allowed to write a strict inequality here because this one is strict, right? X plus 1 is strictly less than delta. So anyway, I'm allowed to write a strict inequality here. But 3's cancel like a miracle, and I just get epsilon the way I'm supposed to. So as I predicted, I left myself a bit too much space, but not a problem.